So 2.7b, example 5, and this is just a continuation. One of the things I want to remind you of, we did this earlier, you have to isolate the absolute value. So we've got to get rid of that 4 first, and that's really the only thing we're doing different from the other ones. Okay, now because the sign is less than, it means that we have an easier journey ahead of us. Because if we draw it on the number line, I'm sure you're getting tired of these numbers on the number line, 5 and -5. That means that the 2x plus 3 represents a number that is somewhere between here or between there. So I can write this as 2x plus 3 is less than 5 or is greater than -5. So it's going to look like that. So remember, when the sign is a less than sign, we can put what's in the absolute value between its positive and negative answer there. So then again, we minus 3 from all 3 places, and we get -8 is less than 2x, which is less than 2. And as we continue on, we divide by 2, divide by 2, divide by 2. -4 is less than x, which is less than 1. Makes it real easy to graph. We have a 0 there, we have a 1, we have a -4, and our x is in the middle. It does not include 4 or 1, and it's everything in between. Okay, example 6 is 4 minus 2t is greater than 2. Okay, so we have the greater than sign. So that means we have to follow the instructions I gave you before. Take the absolute value sign off, change the sign, change the sign. Take the absolute value off, leave everything the way it was. And then we just solve for our 2 sets here. So this is -2t is less than -2 minus 4. So -2t is less than -6. Divide by -2t. And notice we divided by a negative. So t is greater than, we switch our signs, it's greater than 3. Now the other side, we do the same thing. -2t is greater than 2 minus 4. -2t is greater than -2. Divide by -2, divide by -2. T is, switch the sign, less than 1. So then we go ahead and graph it. Like my arrows at the end, looks so nice. We have 1. And we have 3. So if we look at this one, it says t is greater than 3. Greater than, so it's this way. T is less than 1. And that's all we do for that. So if we look at example 7, a little strange problem here. And I'll explain what's going on here. Okay, so what this is saying is the absolute value of 7y minus 1 is less than -2. One of the things that you remember about absolute value is the absolute value is the distance from 0. The absolute value is always a positive number. So what we're saying here is this positive number is less than a negative number. And that can never be true. The positive number can never be less than a negative number. So you can just look at that right away, know the answer is the null set, and we're done. Okay, last one is example number 8. So this number is very similar, or this equation or problem is very similar to 7. we have an absolute value, and we're comparing it to a negative value here. Okay, but remember what we said in example 7. The absolute value of any number is positive. So we're saying that a positive number is greater than a negative 5. That's true. It's always true. So no matter what number we put in here for x, we're going to get a positive number, and that means it's greater than negative 5. That is a true statement. So that being the case, every stinking number in the history of the universe that are real numbers works for this. We could put a negative 3 in there and get negative 18 plus 2, which is a negative 16. But the absolute value of negative 16 is a positive 16, and that's greater than negative 5. So like I say, it doesn't matter what number we put in here for x. When we take the absolute value of it, like we did here, it's going to give us a positive number, and that positive number is greater than negative 5. So the answer for this is all real numbers. There's my symbol for all real numbers. I kind of double the vertical line here. So every number works. It's a real number, and that's it for 2.7.